welcome back to Pocket Run. Hey, where are you going? It's just math, don't run away. Hey. Oh, well.
Okay, we're going to be taking rectangular equations and converting them into polar equations. Remember, or we will use these relationships: x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. Those came from drawing the triangle. So looking at 17D2, we have this equation. Right off the bat, I can tell that equation's a line because I can move y over and x and y are added together, added or subtracted, and that's a line. I don't need to know it's a line. I'm just, in my head, I'm realizing that's a line. So, okay, so what did we say that x equals? Everywhere I see an x, I can put in r cosine theta, because my goal is to change everything from x and y's to r's and thetas. So, everywhere I see an x, I can put in r cosine theta. That's r times cosine theta. Everywhere I see a y, I can put in r sine theta. I still need that 3 coefficient. So that'd be 3, because that means 3 times y. 3 times r sine theta minus 8. Okay, now I'm just going to rewrite this, taking away the parentheses. So I have r cosine theta equals 3r sine theta minus 8. Normally, when you have polar equations, the goal is to get r all by itself on one side and everything else on the other side. Okay, so it's in the form of r equals blah, 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 blah. So this is an r term, this is an r term, so I'm going to get my r terms together. So I'm going to subtract this to the other side. So that goes away there. So then I just basically have r cosine theta minus 3r sine theta. Can't add or subtract sine thetas to cosine thetas. Don't lose that negative. Okay, now I can factor my r out. They both have an r in them. So factor the r out, leaves cosine theta minus 3 sine theta. I'm trying to get the r all by itself, which means I need to get rid of this whole parentheses. Then I divide it to the other side as well. So therefore my final equation would be r equals negative 8 over cosine theta minus 3 sine theta. This equation in polar format is the same as this equation in rectangular. We've been used to seeing this most of your algebra career. This is the same equation, but it's in a polar format with r's and thetas. Okay, now we're looking at 17C1. X squared plus y squared equals 25. When x and y are both squared and your coefficients in front are the same, it's a circle. Okay, so that's a circle. You don't have to know that. I'm just trying to refresh some of your memories and just to put that out there. I want to put this in polar format into a polar equation, meaning it will have r's and thetas instead of x's and y's. So either I'm going to change everywhere I see an x, I'm going to put in r cosine theta, and everywhere I see a y, I'm going to put in r sine theta. There's one more relationship that we know. We also know that x squared plus y squared equals r squared, and that came from Pythagorean theorem. So anytime you see x squared plus y squared, we can replace that whole thing with r squared. So the fact that I have x squared plus y squared, I can replace that whole parentheses with r squared. So r squared equals 25, but I want the format to be in r equals. Generally, 90% of the time it will be r equals something. There are some cases where you leave the r squared here, but 90% of the time it will just be r equals and everything else on the other side. So take the square root of both sides. So that would be r equals 5. And in this case, we're not putting plus or minus because this stands for the radius. So we're only looking at the positive. Because in general, when you're graphing that, basically what you're saying is, there's the center of your circle, and we have a circle with a radius of 5. Counting out 5 units, it would be something like that. That's what that r stands for, radius of 5. So when you have a polar equation where r equals some number, you should already put into your head that that's a circle. And in the rectangular format, it looks like this. Okay, now let's look at 17D1. You have this equation here. I don't have an x squared plus y squared, so I can't just replace it with r squared. So I'm going to go ahead and go to the format that everywhere I see an x, I'm going to replace it with r cosine theta. And everywhere I see a y, I'm going to replace it with r sine theta. Okay? So here's a y, so I'm going to replace it with r sine theta. 2 times, and then x squared, that'd be r cosine theta squared, minus 3 times r cosine theta. Okay, I'm just going to go in order of PEMDAS, simplifying my my exponents. So r cosine theta, this squared means r cosine theta times r cosine theta. Everything gets squared. The r gets squared, the cosine theta gets squared. Because essentially that'd be r cosine theta times r cosine theta. So that would be r squared and then cosine theta squared. Remember, when a cosine squared, the square is written in between the word cosine and the theta. So then we still have minus 3r cosine theta, r sine theta here. Okay, I'm just going to rewrite it to where I get rid of this parentheses. So I'll have r sine theta equals 2r squared cosine squared theta minus 3r cosine theta. Okay, I'm trying to get all the r's together. Well, notice everything has an r in it. Okay, so if I can divide, since everything has an r in it, that means I can get rid of an r out of everything. Whatever I do to one, as long as I do it to everything, it's legal math. So if I basically divide this by an r, divide that by an r, and divide that by an r, that's legal math. Whatever I do to one, I just have to do to everything. Okay? So that means that r goes away, this r and one of those go away, and those go away. So now essentially what I have is sine theta equals 2r cosine squared theta minus 3 cosine theta. Now the goal is to get the r all by itself. So I'm going to move everything that's not an r, like here's an r term, but this one doesn't have one. So I'm going to move this over here. So I'm going to add 3 cosine theta, because the goal is to get the r all by itself and everything else to the other side. So now I have sine theta plus 3 cosine theta equals 2r cosine squared theta. Well, I want r by itself, so I'm going to divide this by 2 cosine squared, which means I have to divide this by 2 cosine squared. So that goes away, that goes away. Then, the book, if you left it like this, it's probably okay, but the book is going to rewrite this to where you have your cosine under each one. They're going to split this up into 2 different fractions. So basically what they're going to do is write it like this. R equals, the tricky thing is to know how to leave them at the very end, how far to simplify them down. That's the tricky part. Even sometimes I get confused on how far to simplify it down. So basically I'm just rewriting this into 2 fractions to where that denominator is underneath each one of those. Because if I had a common denominator like this, and I can rewrite it all over one denominator. Okay? So here you can see one of your cosines goes away. So, and then over here, you can also have, if I change this into a tangent, sine over cosine is a tangent, then I could have, using this sine and one of the cosines, that would be tangent. So I then have a tangent over 2, and then I would still have a cosine theta in the denominator. And over here I had 3 over 2 cosine theta. So now I can combine that into 1 over 1 denominator. R equals tangent theta plus 3 all over 2 cosine theta. And again, it gets tricky on how to know how far to simplify it down. So if you had left it like this, r equals this, that's not wrong, but you can separate these and then simplify a little bit more to where you get down to this.